Hello, you precious cherubs. So we're solving trig equations, and we've got several days of it. This lovely little box O information is something you can read through. I'm going to talk about it as we go, though, so you don't have to spend too much time on it. Okay, so here's the deal. You would have had, let me get a fun color. What fun color? Okay, so like you have seen things like cosine of theta equals negative radical 3 over 2 before. You've seen that, you're okay with that, because you know that you're going to the unit circle, you are finding where x equals negative radical 3 over 2, and you are writing down those angles. It's kind of like inverses, but it's not really, because you're not restricted to a certain hemisphere on the unit circle, but that's still the idea. You're trying to find out where does x, oops, I don't know why I'm writing h, where does x, that looks terrible, good grief, where does x, there we go, equal negative radical 3 over 2. The only thing that's different is the fact that you've got 2 theta, okay? So when you do this, when you find this, your two angles where you've got negative radical 3 over 2 are 5 pi over 6 and 7 pi over 6, okay? Now, if I was writing this as far as all solutions, we would say, okay, 5 pi over 6 plus, I write plus or minus, but most books just write plus. And remember, the reason I write plus or minus is because we go backwards. I don't know why I tried to make that pi look better and I ended up making it worse. That's all right. So 5 pi over 6 plus or minus 2 pi n, right? And then 7 pi over 6 plus or minus 2 pi n. That plus or minus 2 pi n, right? This right here just means, okay, I'm at 5 pi over 6, but then I'm going to go another time around the unit circle, and then I'm going to go another time around the unit circle, and then I'm going to, so it's just all the coterminal angles is really what it is. So what you're going to do is, because it's not just theta, it's actually 2 theta, what you need to do then is actually take your 2 theta and set it equal to each of these, right? That's all you're going to do. You're going to take what was actually there, because it wasn't just a simple x or a simple theta. It's called use substitution. You'll do a lot of it in calc. So basically what we did was we kind of redid this one as the cosine of u equals negative radical 3 over 2. And so that's really what it is. But now ultimately all I have to do then is just divide everything by 2. Okay, so you are straight up dividing everything by 2. You've got like 2 separate equations. And so you've got one of your answers is theta equals 5 pi over 12 plus or minus pi n, right? 2 divided by 2 is 1. And then the other one is 7 pi over 12 plus or minus pi n. Now that's all solutions. So that right there is if I asked you for all solutions. If I asked you for the solutions from, we're going to go pinkish, from 0 to 2 pi, right, including 0 but not including 2 pi, what I end up doing is, well, the 5 pi over 12 is one of them, right? I don't know why I tried to write the 5 separately. And then to get the second one, just take 5 over 12 and add 1 to it, and you'll get 17 pi over 12. And if you try to add 1 again, you're going to get 29 over 12, and 29 divided by 12 is bigger than 2, so you can't do that. And then you take the other angle that you found was 7 pi over 12, or actually it was 7 pi over 6, but you know what I mean. And then you add 1 to that, and you get 19 pi over 12. And if I tried to add 1 more again, I would get 31 pi over 12, and that's not right, because that's too far as well. So then you actually get 4 of these angles in between 0 and 2 pi. And remember, to find them, literally all I did was take the 2 angles that were right here, like those are my first 2 initial angles, and then I'm just going to keep adding 1 pi until I get to like a number that's bigger than 2. Oh, I thought I pressed the next. And you do this, oops, where'd I go? There, I pressed the next button. So it's the same kind of thing for this next one. Again, you have this really this thing right here, which is going to cause a little bit of problems, but it's not terrible. What you're going to look at this is you're going to try to say, all right, instead of cosecant of that thing right there, or that phrase, algebraic expression, I should say, I don't know why I said thing, cosecant of u equals radical 2. Well, guys, cosecant is 1 over sine, so 1 over the sine of u equals radical 2. And you can put that over 1. You're going to cross multiply and divide. So sine of u equals, when you do that, it's really 1 over radical 2, but we know we have to rationalize that, right? So the angles that we get for u are pi over 4 and 3 pi over 4. Those are our two angles where our y equals radical 2 over 2. And so then what I do is we take, instead of just what was there, okay, I've got to do theta over 3 minus pi equals pi over 4 plus or minus 2k. Again, if you only wrote plus, that's fine. And actually, I think my math lab only accepts plus. 2 pi n, okay? And remember, my math lab actually, I think, uses k as well. Wrong. There we go. I don't know if that's going to show up in the video. I went back. This pen is supposed to not register my hand. It's only supposed to register. Oh, I'm sorry. I'm rambling. So 8 over 3 minus pi equals 3 pi over 4 plus or minus 2 pi n. So there's your all solutions. And remember, guys, actually, I shouldn't say that. It's not your all solutions. You have to actually, we need to simplify. So you're going to add pi. You're not adding pi to everything. Here's the thing, guys. This n right here makes like 2 pi n or 2 pi k or whatever variable you're using. It's not like, it's not the same thing. It's kind of like x and y. So like the pi doesn't have anything attached to it. So it's kind of like, we'll just call that the x. And so then you have a pi here, but then you have the n as well. And so it's really like x, y, and you can't combine it. So you're just going to add pi to these two items. So you've got theta over 3 equals 5 pi over 4 plus or minus 2 pi n. I'm just going to stop writing the or minus part. And then theta over 3 equals 7 pi over 4 plus 2 pi n. Now, the 3, you are allowed to multiply by everything in there. So you're going to multiply all of that by 3. Same thing over there on the other one. So you get theta equals 15 pi over 4 plus 6 pi n. And theta equals 21 pi over 4 plus 6 pi n. So this would be all solutions. Remember, all solutions contain the plus or minus 2 pi n thing. And then here's the thing. If we wanted the solutions from 0 to 2 pi, remember, you start with these ones, these first ones right here. But guys, you like 15 divided by 4 is almost 4. And 21 divided by 4 is over 5. So there are no solutions. None. No. Empty set. However you want to write it. There's no solutions in that range. Okay, next one. All right, cotangent of 3 theta equals 0. Okay, and here's the thing. You can do a couple different ways. Like, remember, cotangent is x over y, right? And so basically, remember, for any fraction to be 0, you need the denominator to be 0. So you're looking for wherever your x is 0, and your x is 0 at pi over 2 and 3 pi over 2. So you can, if you wanted to, write pi over 2 plus pi n for both of them, right? Because remember, that'll take care of it. You can also, like, if you weren't thinking about it, you can write pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. Remember, we could have done this like this right here because pi over 2 is straight up, 3 pi over 2 is straight down. They form a straight line. They're 180 degrees apart. So that's where this comes in, the pi over 2. You take the smaller of the two angles and just add pi instead of adding 2 pi, okay? So because we can write it as 1, I'm just gonna work with this one right here. So you set 3 theta, right? 3 theta, that's what this is. It wasn't just plain old theta, it was 3 theta equal to pi over n plus 2 pi n. And of course, you're just going to divide everything by 3. So theta equals pi over 6 plus, oh, crap. This should be a 1 pi n. I'm so sorry. That should be a 1. So pi over 6 plus pi over 3 n. So these are all of our solutions. And then if I wanted from 0 to 2 pi, those solutions, so remember what you're going to do is you're going to start with that first angle you got, and you got pi over 6, and then you are just going to add 1/3, right? And you can do this in your calculator. That's all you got to do is just add 1/3. So 1/6 plus 1/3 would give me 1/2, so pi over 2, plus 1/3 would give me 5 pi over 6, plus 1/3 would be 7 pi over 6, then 3 pi over 2, then 11 pi over 6. If I went farther, or if I added 1/3 again, then I would be past 2. Remember, you only go up to 2. All right, secant squared equals 4. This one's nice because notice your theta is just a plain old single theta. You don't have to worry about like doing U substitution or finding your angles and then basically finding your angles and then solving little mini equations within the problem. So what you're going to do here, take your square root. So you're going to get secant of theta equals a positive 2, and secant of theta equals a negative 2, right? And so remember, secant is 1 over cosine. So that really means when I cross multiply and divide, I'll get cosine theta equals 1/2. And then cosine theta, this one over here, will give me negative 1/2. So I need to find my angles where I get 1/2. So this is so not cool. This pen is supposed to like keep the iPad from recognizing my hand, but it's not doing a very, it's not doing a very good job. Like my wrist keeps touching buttons that it shouldn't be touching. All right, so we've got from positive 1/2, we've got pi over 3 and 5 pi over 3. And of course, we would add our 2 pi n, or write plus minus, and remember you can use n or k, doesn't matter. And then 2 pi over 3 and 4 pi over 3 would give us the negative 1/2. So there we've got this. Now, you can write them all like this if you would like. It's not a big deal, but remember, these guys, pi over 3 and 4 pi over 3 form a straight line, and 2 pi over 3 and 5 pi over 3 form a straight line. So you can actually write them just as pi over 3, oopsies, I don't know why I wrote a 2, pi over 3 plus 2, nope, again, goofball, plus just 1 pi, and there we go. That takes care of those two reds that I connected with the red line. And then 2 pi over 3 plus pi n takes care of what I connected with the blue line. So there's your, again, all solutions, right? And I'm going to shrink this just a little bit. When you go to do your solutions for, that's not cool. It went to the next page. So not cool. I hope it like isn't messing up with the recording. So we've got 0 to 2 pi, right? And so again, you start with your first angle and then just you're going to start adding 1. So pi over 3 plus, so basically 1/3 plus 1 is going to be 1/3. Yeah, that's going to be 4 pi over 3. Yeah. And then add another 1 would be 7 over 3, and that's not going to work. You can't do that. So then I'm going to do 2 pi over 3. And then, oh, yeah, no, actually, there they are. 5, 5, or 3. It's the original four angles that we just have found. Which makes sense because, again, we were dealing with strictly a simple theta. Okay? And guys, it should be noted that we should be checking these. You can always check them in your calculator real quick. You don't have to show a check, but you're going to want to actually just double check them to make sure that they're that you found the correct answer and that you don't have any extraneous answers. I think I've got an example. I don't know if it's day 2 or day 3 where there's an extraneous answer, so I'll definitely get there. But just in the meantime, you should be checking them as you go.